And we are live. Okay, you guys. We had a faculty meeting. We talked about math and all the other classes, and I think you have to look at what the state wants, and that is we need to keep doing school. If you guys are lazy and don't do it, then it's just like school. So anyway, let's move on because you guys are doing a great job. I'm proud of all of you. I'm here to help you any way I can. So if you want a good grade, just try. Text me, whatever you want to do to get a little bit of help. I want everybody to be successful, okay? Okay, so first of all, let's look at yesterday's homework. It was actually really easy. I like this chapter. It's pretty easy. So, that's 9, that's 3 and 3, so the whole thing's 6. X turns out to be 2, so you plug in 2, and that value is 6. If I draw the perpendicular bisector, it's down 1 over 2. It's a negative 1/2 x plus 1/2. It goes through it to half. Number 5, 20, 20, so the whole thing goes 40. 5 and 5. This one, x equals 1, so you plug in 1, and this value is 4. Okay, so that's the homework. Pretty darn easy. Okay, now, today's lesson. Okay, so, just want you to watch. Okay, so, what we want to do is this. We're going to talk about a thing called a circumcenter. Okay, a circumcenter is going to be a point that happens to be the center of a circle. Now I don't see a circle, they just draw a triangle. So what happens is this. If I want to put a circle around the triangle, and when it's circum, it's on the outside, in center, inside, but circumcenter is on the outside. So if I want to put a circle on the outside of the triangle, what I've got to do is find the center that will let me draw a circle that goes all the way around it. Okay, now, so what I did is this. To find the circumcenter, you have to draw the perpendicular bisectors. Okay, and I did this earlier. Perpendicular bisectors. So I took my ruler, I measured each length, found the middle because it's a bisector, right? Bisector, so I found the middle, measured it, and then I drew 90 degrees straight up. Now it does not go through the angle, the vertex of the angle. It could if it was an isosceles triangle or an equilateral triangle, but it doesn't. Okay. Same thing here. I found the middle, drew 90 degrees. I think I was a little bit off on this one, but that's okay. Here, same thing. I found the middle, drew 90 degrees, and what I did is all three of these intersected in a single point. That is my circumcenter. Call that P. So P in this case, P is my circumcenter. If we were in class, I'd have everybody draw this and construct it, but we're not, so this is the best we can do. So then, if that's true, if that's the center of a circle, let's draw it. Take my compass, and I've already kind of made it sort of work, and if I just draw, and it may not be perfect, because remember I did this, but if I did it right, oh shoot, I should be able to draw a circle that goes around my triangle, and there it is. What do you know? Not bad. Okay, so I found the center of the circle by using the perpendicular bisector, so I know that this side's equal to that side, this side's here equals to that side, and this side here is equal to that side. 90 degrees, so they're all 90. And what happened when I did the perpendicular bisectors, they intersected in a center point called the circumcenter. I was able to then draw a circle around my triangle which touches each individual vertex of my triangle. Okay, now, what's the big deal? Well, here's what they don't show you. And once you draw this, it seems really obvious to me. But that's why I like to draw it. We know that radii of a circle, radius, okay, radius. But if I go radii, that's more than one radius. We know radii of the same circle are all equal, right? So that means that, you ready? This line segment here, because that's a radius of the circle, is equal to this radius, which is also equal to this radius right here. And that's what you won't see on today's lesson. They won't show the circle, they'll only show the triangle, okay? Now it seems obvious. This side's equal to this side equals this side. So let's write that down. Here's what I know. I know that AP is congruent, remember that symbol, is congruent to BP, which is congruent to PC. Okay. Now, once you draw the circle and put in the radii, that seems pretty obvious. Okay, so we drew a circumcenter, found the center of a circle, goes around the triangle, and then the big key, big bath key, is all of these radii, of course, are congruent. Okay, now, second construction they do, okay, is a thing called the incenter. So I've kind of set us up, but we're going to bisect each angle. Okay, so I took my protractor this morning, and I looked at the angle. This turned out to be 40 degrees, and I used my protractor 20/20. So I cut the angle in half. I used my protractor this morning, and I cut it in half, and I bisect the angle. I used my protractor this morning, cut it in half, and they all intersect in a single point. Okay, now that's the incenter. Okay. So angle bisectors. If that's the case, then this angle is equal to this angle. This angle here is equal to this angle. This angle here is equal to this angle here. Okay? So when we do all the angle bisectors, they intersect in a single point. Let's call that P. And that's called the incenter. Now why is it called the incenter? Because we're going to put a circle on the inside. Incenter. We're going to put a circle on the inside of the triangle. Okay, so let's see how well I've done on this. So let's see. I need it to touch, need it to truly be inside. So I'm going to go ahead and make my compass a little bit smaller, a little bit bigger. Let's see how good I did. And remember, it might not be perfect, but let's see how good was Mr. Davies this morning. Yeah. Oh, hold on. Get something I can poke with. All right, poke my journal. Poke it down so it doesn't move. Hey, that's not bad. Look at that. Look at that. Look at... Oh, doggone it. Look at that. I didn't get it there. Should be touching right about there. Alright, so I'm not perfect. If I'd done it right, it should touch, okay? So, if I'd done a really careful job, I would have gotten a perfect point. So that's my incenter. Point P is my incenter. And what it is a circle on the inside of the triangle. Now when we say inside, it's got to touch. It has to touch the triangle all the way around. So it's a circle inside the triangle, but it has to touch. Now here's what happens. When it touches, let's see exactly where it touches. It seems to touch right about there. Let's call that point M. Touches right about there. Let's call that point N. It seems to touch right about there. Let's call that point O. All right. So here's what we know. Same thing. Radius of a circle are all equal, right? So if I draw in this radii right here, and if I draw in this radii right here, and if I draw in this radii right here, then what I get are all three of these to be equal. They also happen to be perpendicular, okay? Now again, this is my drawing, so maybe you guys, if you get bored, you could try it and see if you get a better drawing than I do. So here's what we know, okay? This is called the incenter, and what the incenter does is makes a point inside the circle. If you draw the circle itself, it should touch this triangle. It touches it barely, which we call a tangent. And so here's what we know. We know these points P, N, PM is congruent. Remember that symbol, congruent. PM must be congruent to PN, which is also congruent to PO, because they're all radius of the circle. We also know they're perpendicular. Okay, now that's what this lesson is all about. So if we take a look at our notes, okay. All right, so take a look at our notes, okay. So what the book doesn't do, which I really think is kind of a bummer, is they talk about perpendicular bisectors. Okay, so hold on, let me look at my notes. Perpendicular bisectors. Ah, that's my circumcenter, right? So if I were to draw the circle on the outside of this, it becomes pretty obvious what I'm looking for. Now you don't have to do this, but I think it's really nice to put it in. So draw my circle. And then it seems obvious to me that this side, PG, has got to be equal to this side, GC, because I radius the circle, which has to be equal to this side, AG. Okay, so that's what I know. So if they want to find, in example 1, whatever we know, well, I do know that it's a bisector. So if this is 8, this has to be 8 right here. It's got to be. If this is 9, then this radius is 9, then this radius here is 9, and this radius here is also 9. Okay, those are things I definitely can get from that picture. Okay, now, same thing. Put my circle around it because it's a circumcenter. I think it's easy if you draw in the circle, but you don't have to. A little bit smaller. Okay, if I put in the circle, it seems really easy. Okay, here's my circle. They don't draw it in. I like to draw it in. And here's a radius of the circle right there. Here's a radius of the circle right there. Here's a radius of the circle right there. Okay. CG is right here. Well, if that's 10, then CG's also got to be 10. That's 9, that's got to be 9 there, but CG is definitely, if that's 10, CG is also 10. You see how easy it is? If you put the circle around, you can find the radii of the circle. Okay. And then PS. Okay, so on this one, again, perpendicular bisectors. So if we drew in our triangle, you can see which ones are the radii. You don't have, again, you don't have to do this, but I like to do this. Okay. I don't think this is. I think this is an incenter because they say it's a perpendicular bisector, but I think this is an incenter by the perpendicular. So I'm gonna draw a really small little circle. I don't even know if that'll fit. Okay, so basically there is a circle, and it's not gonna fit. It's got to be like right here. Here's my circle. Okay, and here's a radius. Here's a radius, and here's a radius, right? So PS would have to be 2 because it's the same as that. Okay, all right. Hopefully that's pretty easy. That is not a circumcenter. That's an incenter. All right, now number 4. Here's where it gets a little bit trickier, but we can do it. So let's graph it. So we want to find the circumcenter of the triangle. All right. Take my graph paper. Do my XY axis. Hopefully this is making some sense to you. This one's a little bit harder, but we can do it. Okay, point at 6, 0. Okay, 1, 2, 3, 4, 5, 6, 0. There's J. 0, 0. There's K, and 0, 4. 1, 2, 3, is L. Now, if we're looking for the circumcenter, let's see now again. Circumcenter, 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 perpendicular bisectors. Okay. Alright, so here's a triangle. And let me draw my triangle for you. Okay, there's my triangle. Let's highlight this. Okay, there's my triangle. So, let's take the easy one. Perpendicular. Let me write this down. Perpendicular bisector. Alright. So bisector. Let's take this side here. KS. Bisector means middle. There's my middle point. Okay. Perpendicular is at 90 degrees. That's actually really easy on graph paper. It's just going to be straight up. Okay. 90 degrees. There's my perpendicular bisector. Okay. Let's do the other easy one. Turn my graph paper like this. Okay, again, bisector. That's the middle. Right there. That's the middle of the line at 90 degrees. Let's draw that. Okay. Sure seems like that's my point, but let's take a look at this line. The middle of this line is here at 90 degrees with the opposite slope. Instead of up 2 or 3, it's going to be 3, 2. It's going to go right there. And sure enough, that point right there, let's go back to what I have on my notes. Sorry about that. Let's go back to my notes. I have found a point that I can draw a circle around. So I'll do that right quick. Let's see how good of a job I did. Okay, there, oh, not bad, there, oh yeah, I got it. So my center of my circle allowed me to draw a circle that touched each of my vertices. The coordinate of my circumcenter is at the point 3, 2. Alright, so that's about all I have except for one last thing. Okay, let's take a look at problem number 6. It's an end center. So what do we know about the end center? Okay, we know that this is equal to this, which is equal to this. Okay, and you can put the circle around to check it. So if we know that PJ is 4x minus 8 and PL is x plus 7, we can take our 4x minus 8 and set it equal to my x plus 7. Solve for x. Minus x minus x. 3x minus 8 equals 7. Plus 8 plus 8. 3x equals 15. Divide by 3, and x is 5. Okay, now if x is 5, and I want to find pk, well, let's plug it in. I may as well plug it right in there. That looks like the easiest place to plug it into. If x is 5, I put 5 right in there. 5 plus 7 is 12. So that tells me that this side is PL. PL, that's 12, which means that's got to be 12, and that's got to be 12. Okay? And so then problem number 7 works the same way. Okay, that's all I have except for your homework. You need to know what homework to do, and please show your work. Here's your homework for today, page 200, 1 through 10 all. Let's go check that page 200. I'll show you where you're at. Page 200. Here it is, 1 through 10 all. Okay, that's all I have. Again, email me, text me, whatever. If you have any questions, I want everybody to get a good grade in this class.